Hello, myself Dr. Animesh Chaturvedi, and my co-authors are Professor Aruna Tiwari and Professor Nicolas Spyratos. We are going to discuss this paper. So, motivation about the work is we have given a state series of multiple state, and rules could be interesting in one state and not interesting in another state. Our contribution are like we defined evolution rule, stable rule, and these three things, and then persistent matrix, SNP matrix. We, then we have also described our algorithm. Uh, we have presented experimentation results, and we have given thorough literature survey. So first we'll start with the evolution rule and stable rule, and this system network database definition, network evolution rule definition, NERs, and stable NERs, then persistent matrix and SNP matrix. So suppose we have given that state series and we want to do system evolution analytics, and for that we proposed stability as the measure for evolution rules, and that stability is the fraction of the state in which that rule is interesting. And stable rule are basically a kind of evolution rule having stability greater than min step. Then persistent matrix is quantified as the measure of persistent entity connection. Now, this database series could represent that state series, and various rules could be generated like X implies Y. So, if that support and confidence is above the threshold, then we say it as interesting. Then evolution rule is that if this rule is occurring in multiple states, then it has some stability, means how many fraction of states in which it is occurring. Then we calculate we find out stable rules which has stability above the threshold, that is minimum stability is minister. Then connection pair is basically defined as numeric and R, that is for the source entities and target entities, and this have set could be created of those connection pair that actually defines sysnet DB. For ith state, it is said to be sysnet DBI. There could be n such database, 1, 2, up to n. So these together said to be sysnet DBs. Then suppose support is being calculated like the X union Y is occurring how many times divided by the total number of connection pairs. Then what is confidence? Confidence is Bayesian probability, just like in association rule mining. So this network rule are basically said to be in testing if it has support and confidence greater than the thresholds. And NER is said to be distinct and identical network rules occurring in multiple states. Then stability is defined as number of states in which this rule is in testing divided by total number of states. Then NER is basically said to be stable NER when stability count is greater than the threshold. Now, mean persistent connection is directly proportional to min step. Persistent connection is directly proportional to SR count and inversely proportional to evolution rule count. Then we combine these two facts and drive the formula like this. Then persistent matrix could have low value for uh, low minimum stability and less as stable rule count. So then we have various type of rules like generation for the persistent, and these rules would actually denote that they are stable in nature. Now this could have low value up to 0, and that is for the volatile system. Now high value could be for the high value of min step and that stable rule count. Then we have many such stable rules, and this actually denotes persistent entity connection, and higher value could be up to 100, and that says that identical systems are there, and these identical systems are don't change with time, and lower and upper bound are ideal condition. So these based upon the three system domain fractions, the two fractions, this persistent matrix depends on these three reasons. Now using the persistent matrix, so for the n state we have persistent matrix n value. Then we could have persistent matrix value for n plus 1 like this. So it can be either greater than, lesser than. So these three conditions would be generated. So illustrative example, like for this graph, we have generated this system network database with three different connection pairs, and we apply network rule mining to generate network rules. So here there are three databases for one, two, three, which are generating three different set of network rules, and these network rules are connected together, collected together, and then stability count is being calculated, and these stability count is let you drive the stable network evolution rules. So the thresholds were used like minimum support is 2, minimum confidence 0.5, minimum stability 2. So these we put it in the formula and we'll get the persistent matrix value. Then a stable network analytics algorithm, we can say it uses mean-stab as major factor and generate network evolution rule and stable NER. So then we want to calculate the system network persistent, and this tool is being created. Now this there are pre-processing it could do, like S1, S2 up to Sn could be generating evolving rules, evolving networks, and then these databases are being converted to some network rules by network rule mining. So this pre-processing is the first step for the generation of system network database along with the index file. Then rule mining is being applied, that mining NER and SNER. Then a collection of the network rules are generated, and then distinct rules are merged to create network evolution rules. And that if some network evolution rule have some stability greater than min step, then we say it as stable network evolution rule. And then in the end we convert that entity ID based rule to the entity name based rule. Like rule could be 1 comma 2 implies 3, but it's hard to read for human. So the rules are converted like their according to their ID, like butter comma jam implies milk. Then is system network persistent could be having the formula, we can calculate this SNP matrix with the values that we have got. So this all these things is automated as a Java tool, and it generates the artifact that we have discussed. It uses the three steps: pre-processing, mining, and indexing. So the domain information is basically like we did for the software, nature, language, retail market, IMDb, for quantifying stability and persistent, to do system evolution information generation. So these are the like for the software evolution, I think Hadoop is being pre-processed to create call graph with caller and callee procedures, and this nature language is being created as word network, and this market evolution analytics is done for the purchase network, and then movie evolution analytics is being done for the positive sentiment and negative sentiment. These are the various uh, database repository that we have used to do the analysis. Then experimentation on the four domains we have done. So these are the four domains that we have studied. And what we have studied, we gathered stable network evolution rule for explored value of minimum support confidence and exploited value for the minimum stability. So starting with the first 15 jar of Hadoop is processed to create 15 evolving network, and this create operation or procedure is mostly being affected by the, and this actually affect convert. So this create and convert are interrelated to each other, these procedures. We did 9 experiment for such rule generation for 15 versions. So these are different three thresholds, different values, and we calculated SNP matrix based upon the formula and these values in the table. Similarly, for 13 centuries, this type of analysis been resulted for modern English language is mostly translated from Vulgate and Greek. these rules are automatically generated. Then again, the same experimentation has been done for various thresholds. Then the 13 decades we have studied for the multi-sports event, that Asian games are basically regional games, world games are being international games. These are being uh, automatically deduced by the rules. Then this product is being majorly purchased by this customer. So these type of information are being generated, and we can do target marketing. So this, suppose premier word is occurring in the movie names, it belongs to the short genre, it says, and we can target and find out these type of words and target the positive audience. So we can target negative audience as well with the negative words occurring in the some genre. So sin is mostly occurring with the drama genre, and with this information we can find out all such words and target the negative audience. Now the system network persistence could be done like this. There are six series for six evolving system, and there are nine experiments. Result are being plotted like this. For nine experiment, results are plotted like this for SNP matrix in y-axis. Then related work and discussion. So like GER, graph evolution rule, LFR, and GRAP, all these things, some similar rules are being proposed earlier. These are the related works. Then we in the table we have discussed contribution of these rules in the sequential order in which they occur: 2009, 2010, 2015, and then future works of these things, and the uh, our previous publication related to this. And then this, suppose NER is equivalent concept to GER, LFR, then NER is a new method to be proposed to identify NER. Then we also optimize it as the stable NER. Then for this we compared the experimental result for SNER count and NER count, which shows that SNERs are lesser in number and more significant and interesting. Then there could be techniques which are based upon network mining and rule mining. They are independent of time, but there are some time mining technique which are independent of interconnected entity. So we have intelligently combined the three: network, rule, and evolution mining, to generate some information, better information. In conclusion, we defined all these things, and we propose a algorithm that could be applied to evolving networks, and we propose that threshold mean step, the stability and persistent matrix for the entity connection we find out, and then four domains we studied for six evolving systems, six state series. And then we have done the NER, retrieved NER. We have done nine uh, experiments. We have generated system evolution information in terms of stable NER, which is interesting, non-obvious. We did all these things. We can in future, this all these things could be done for the new mining technique, and it could be done for the large network or big graphs, and these experiment could be done for the other data set as well. So related work, we can say, for this citation, you can use this citation for referring this. Then previously we have published uh, pre- previous work of this paper on IEEE transactional computational intelligence, that is about minimum stability. And we have also publishing a stable hate rule generation technique in the same venue, with that this title, min offense inter agreement hit term list. And we have done these two work for the system evolution analytics. Then we have also done system network complexity analysis, and we generated system neural network to do system evolution recommender and deep evolution learning. Then thanks a lot for all of you for listening talk. And if you have any query, please email me. Bye. Thanks a lot and for having patience.